Hello and welcome to this episode of Math with Martinez. In today's video, we are going to graph and write the inverse of a function using function notation. So let's go ahead and get started with finding inverses of functions. I want to first begin by looking at how we find the inverse from a table. If you're asked to find the inverse of a set of ordered pairs, all you need to do is switch the x value and the y value. Remember that in this relation here, this set of ordered pairs, the x's are always the first value in your ordered pair, and then the y values are the second value in your ordered pair. So if this was, let me get my orange pen real quick. If we're saying that this original set of ordered pairs, oh, there it is. Sorry, I couldn't find my marker. If this is a relation, we'll call it R, then if we want to find R inverse, the inverse is going to be that we will take and switch all of these ordered pairs. So we will start and flip those around. Do you see how this is going to end up going? We're going to have 0, 0. That would be that first pair. Nothing really changes a whole lot there. But then we would have -3, 2. Do you see how the x and y switched? And then we would have 5, -4. And then we would have -1, -2. And last but not least, we would have 3, 4. So that is the process of taking and finding the inverse from a table or from a set of ordered pairs. Just like that. You've just got to reverse or switch the x and the y value. Now let's look at from a graph, what do we do there? When we graph functions and their inverses, they always are going to reflect across the line y equals x, which is this line right here going through the origin, dividing this quadrant 1 and quadrant 3. It's a line whose slope is 1, so you just go up 1 over 1, up 1 over 1, and again, it is located intercepting there at the origin. And so inverses are going to be perfect reflections of one another. So if I were to have a graph that looks like, let's say it starts here and then it goes like that. So if I were to have this as my original function, we'll call it f of x. If that is the original function, then the inverse is going to be reflecting that. So they're going to be equal distance away. So what's really fascinating here is, like we saw before, what do we need to do? We need to switch the x and y values. So we would take these points and switch them. So this point, instead of being the point 0, 2, it's going to be 2, 0. Boom, boom. Do you see how it's kind of reflecting across that pink line? And this point, this is the point 1, 4, but instead of going 1, 4, we'll go 4, 1, over 1. And then this point up here is the point 2, 6, but instead what we'll do is we'll go to 6, 2. And we can keep doing that. And what's really neat, though, about all this is once you've got these points all plotted, you can see how they reflect really nicely in this line. They are reflected about that line y equals x. They're equidistant from that line, and they're perfect reflections across that line. Now, I also have a really cool calculator tutorial right here that you guys can use on our classroom set of TI-84 calculators. If you want to graph an inverse function, you just follow these steps, and that'll allow you to take an original function like f of x, and then it will go ahead and graph f inverse of x. It'll give you that inverse function. And remember, if the question is asking you if the inverse is a function, you can always run the vertical line test across it to know if that inverse is in fact a function. Now, really important, I've already kind of hinted at it, but the inverse of a function is always written as f inverse of x. And how do we read that? That is read as f inverse of x. That's how you read that little statement there. I want you to be able to, just like we read in an English class, to read correctly mathematical statements like this one. So how do we find the inverse of a function? Because like we're given here examples of functions, and we are asked to find their inverses. So how do we do this? Well, we followed these 4 little steps, where step number 1 is to replace f of x with y. Let's go ahead and do that step in pink. So I'm going to do this replacing f of x with y. And I'm going to show that here in this first example. So instead of writing f of x, I'll write y equals. Okay, then we move on to step number 2, which is to switch the x and the y. So what happens here is where there was a y, I will replace that with an x. And where there was an x, we switch it and write y. The signs don't change, nothing else changes, the numbers don't move at all. It's just switching x and y. And then we move on to the next part, which is to solve for y. We want to get y by itself. So how do we get y by itself? Right now it's y minus 7. What's the opposite of minus 7? We need to add 7. And whatever we do on one side, we do to the other side of our equal sign. And so what does that give us? That gives us x plus 7 equals y. Well, look at there. I've done it. I have now gone ahead and got my y all by itself. I have solved. So now our final step is going to be to rewrite, instead of y, I'm going to rewrite this as, what is this going to be? F inverse of x equals the rule, which is x plus 7. Remember, when we're using this f inverse of x, that is in lieu of or replacing that y. So what is y equal? X plus 7. What does f inverse equal? X plus 7. That is our inverse of our function. Let's do another one. Let's do example number 2. All right, so we begin at the top. Step number 1, replace f of x with y. Step number 2, switch the x and y. Step number 3 is to go ahead and solve for y. How will I do that? Well, right now what I have is that I am dividing by 3. So what's the opposite of dividing by 3? Yep, you guessed it. I need to go ahead and on both sides multiply by 3. That will eliminate that operation. So I have 3x equals y minus 8. Okay, so what should I go ahead and do to get the y by itself? I'm going to bring my work back up over here. What do we need to do? Right now it's y minus 8, so we will need to add 8. And whatever we do to one side, we do to the other side. So we'll have 3x plus 8 equals y. And our y is now isolated. We have finished solving. So we can go ahead and rewrite this using that function notation to denote it as the inverse of f of x. And what's the rule? 3x plus 8. There you have it. We've got just a couple more down here that I want to show you. These are, the first 2 examples were linear functions, but these are a little bit larger exponents that we're going to be looking at. And so we need to be able to work with the opposite operations. So let's go ahead and try this example number 3. Again, start by replacing f of x with y. And this part right here is just telling us what the domain is. That's all that this is saying. And in our future videos and discussions, we'll talk about why that's really important. But I went ahead and did step number 1. Now step number 2 is to switch x and y. So I have x equals y squared minus 9. Then we need to solve for y. Well, the very first thing that we'll want to do is go ahead and undo PEMDAS in that reverse order. So you want to undo the simpler operations first. What is more simple, to square or to subtract? Well, obviously it is subtracting. So we'll need to add 9 on each side. That gives us x plus 9 equals y squared. Now we need to undo squaring. Well, what's the opposite of squaring? Make a little note to yourself right here. What is the opposite of squaring? What is the opposite of squaring? It is to take the square root. And do you remember what that square root symbol looks like? Remember that? That little square root symbol? So that's what we're going to need to do. We're going to take the square root on both sides. And when I square root a square, that will cancel those operations. And so what do we have? We have that the square root of x plus 9 equals y. And y is now all by itself. So we can go ahead and write this using our function notation. The rule for the inverse f of x is the square root of x plus 9. So the big takeaway here, remember the opposite of squaring is to take the square root. And that's going to come in handy when we look at example number 4. Now example number 4 is not squared, it is actually cubed. So let's see what we need to do here. Well, again, step number 1, replace f of x with y. Oops. My bad. Let me wipe that out. I don't know why I closed my parenthesis there. There we go. Okay, and then step number 2, switch your X and Y. And then we start step number 3, solving for Y. Now I want you to notice here that everything inside this group is being cubed. So I can't work inside the group until I've removed the grouping symbol. But I have even something outside the grouping symbol. That's going to be the first thing I want to take care of. Outside the grouping symbol, I have -6. So what should be our opposite operation? I need to add 6 on both sides. That gives me x plus 6 equals the quantity y plus 4 cubed. Now, I cannot undo this plus 4 until I've undone the group. This whole group is cubed. So what do you guys think is the opposite of cubing? Well, what was the opposite of squaring? It was taking the square root. So what we need to do here is take what is called a cube root. I need to take a cube root, and we show a cube root with a little 3 on that little foot of your root. Okay, so cube root of something cubed, that's going to cancel out. And on this side, what we'll have is y plus 4. Over here, we have cube root of x plus 6. Last thing, we've got a plus 4. So what's the opposite? Subtracting 4. Now, I want you to be aware that we are subtracting 4 after we've taken the cube root of x plus 6. So it is outside of the root. It is not inside, it is after that root. So we would write our final statement. F inverse of x is the rule where we take the cube root of x, add 6, and then subtract 4. There you have it, ladies and gentlemen. 4 steps in order to algebraically find the inverse of a given function from the equation. That is it for this video, where we looked at finding the inverse from a table, graph, and equation. If you all had any questions, will you please